When assigning material parameters, we just picked an object or picked a face and gave it a parameter, and that was it. Then there's that we filled in properties or edit type. With moving geometry around, it's more complicated. And it's helped me to think of a Revit object as a body. That's the geometry, let's say the skin that we see, the flesh. And then within Revit, we create what's called reference planes, which are, if you like, the bones that the flesh is attached to. And then there are the muscles that move the bones. In Revit, those are the dimensions that move the reference planes. And then the parameter is the name we give each dimension so that we can control height, width, depth, and so on by their names. And I think what we'll do is start by exploring an existing family or two, and then make a new really simple one just as a demo in class, and then go on to some more involved ones and see how far we get. The assignment that's going to come out of this is probably to take one or two of the families you've already made and add parameters to them so you can place your table in your project and then create several types of it with different dimensions without editing it at all in the family editor. All will be clear by 3:30. Let's just look at, let's say, a wall cabinet. I'm going to go to Architecture, Component, Place a Component, Load Family, Casework, Wall Cabinet, sorry. Single door plain old cabinet. Not wanting to stick to the wall. Oh, sometimes I did that load place component, but it's still here stuck on pendant light fixture, expecting to be placed, which can only be placed from a ceiling. I don't have any of those. So I need to go down and get that wall cabinet. Base, oh, I guess it's called wall cabinet. Listed here under upper cabinet. Okay. So there's that. It sticks on the wall. And as you see, when we select it, the only thing that we control, the only dimension in properties, is how high it is off the floor. And those are usually 4'6". Allow a 3-foot counter and then a 1.5 feet. It's when we go into edit type, is where we control the dimensions of the object itself. And that's really the way that Revit's really set up, is that the family determines the basic geometry, and in the type, you control the dimensions that are linked to that. In edit type, we don't change the geometry like adding a door. We just change the dimensions of the pieces that are there. So if I decide that I want to make this 4 foot high, I just change the height right there and apply and make it 4 feet high. Okay. So what does this look like in the family editor? We'll look at it first in a floor plan view. It's a family that is like casework, wall-based. And it knows that it needs to go on a wall. We're here in a plan view, sticking to a wall. And I just want to show you that in plan, we have this line right here is the center reference plane of this object. And we're saying that the whole thing wants to be 18 inches wide, 1'6". That wants to go equal distances from the center line. So not only do we dimension these two reference planes 1.5 feet apart, but we also measure them as equal distances from the center line to there and from the center line out to there. We'll see how this works. Now let's look at a front view, which is the placement side, the side of the wall that it gets placed on. And we see essentially its other dimensions, but we see here how high it is to the top off the floor, how high the actual unit is, and then this line that indicates the door swing is always going to be coming to the center of that. And I think if we go to a left side, let's go to the right side. We'll see in the right side view is where the depth of it out from the wall is established. So how does all this actually work? Let's close these down. Let's just make a lump of stuff that sits on the floor. Just X, Y, and Z dimensions. We're going to go to File, New. You have to hover over that for a little bit, or you can click here to make sure you come down to File, New Family. A set of custom components to use in projects. And we have to pick the kind of thing this is, and I'm just going to say Entourage. And that'll take us into the family editor, where I find the most intuitive way to create a family is to model the pieces first with approximate sizes, and then assign all the dimension and controls to it later on. So you don't have to think ahead of where do I need all my lines and settings. You just make the thing first and then create it. So I'm just going to say it's an extrusion rectangle. I'll start out with it being like 2 foot by 1 foot and make it 4 feet high. Okay, so there's that. I'll move this. Again, I want to center it on the intersection of the 2 reference planes. Move from middle of side to the reference plane over to there. Move middle to and there. Okay. So now this is what I've got. We'll look at it in 3D. And here's our thing, 2 foot by 1 foot by 4 feet. Now I want these people to I want to be able to control these from out in the project. I don't have to come back here and change them. So what I'll do is go back into my reference level and create 4 reference planes that will control where those sides of the object are located. So that's under Create Reference Plane. And these are true planes. They extend infinitely through space. I'll make one right here. And I like to drag them down so I can see the relationship between the side and the line. Reference plane. I'll do that. And then I need to tie the geometry to those. And the easiest way to do that is to pick the thing, hit Edit Extrusion, move the line off the reference plane, bring it back to the reference plane, and lock it to the reference plane. Do the same thing over here. This is tying the flesh to the bones, this being the flesh and these being the bones. And we'll say OK. So now when I move the bone, the side of the object moves, which is exactly what we want to happen. And now to put dimensions on these that will control the reference planes, I'll put a annotate dimension, one from here to here, and this will end up being our overall width. And then I'm going to go from here to here and onto there and say make those 2 equal. So that these two main reference planes are locked in place, and everything else moves off them in whichever direction. So click the equal button, and those now become equal, and it becomes centered on it. So the trick here is to make sure that the dimension will move the reference planes, which move the geometry. Just as we attached a material parameter to our objects, I'm going to attach a dimensional parameter to this dimension. And I do that by picking it here. And then I'm giving this dimension a label, thereby creating a dimensional parameter. And again, we're sort of in that parameter properties things, but this time we're dealing with length. And I'm going to just call this, let's call this width and depth and height. Width, and it'll be by type. Okay. I can dimension things here in the plan to set that to be equal to a foot. It's once you see width equals a distance, or length equals or height equals, that you know you've got something that we have a name that can be reported back to our model, so we can change the dimension in the project and have it stretch as it sits on the floor with everything else. So I'll get rid of that, just not to confuse things. And the way we can tell that this works is over here under Family Types. We will be set up with the dimension with, and this is just a preview of what we're going to get back in the model. And if I set this to 5 feet, apply, then this one jumps to 5 feet, and these 2 are required to be equal, so they both go to 2.5 feet. Let's do the other dimension. So we get a depth. We're going to create, cancel. Create reference plane. Drag that out. CS. Here's that. we'll give dimension, edit extrusion. Now lock this guy to there, lock this guy to here. And now we have our object completely controlled by these 4 reference planes. So annotate, aligned. Make those equal. And these can be, it doesn't matter where you put these as long as they're connected to the thing. And then I'm going to label this dimension as depth. And that's all I have to do. So when I go over to properties here, I get depth, and I can set that to be 2 feet. And now we can control that completely that way. Right now, this is 4 feet high. Let me take this back into the project. You know, this doesn't have a name yet. Let me go back to this guy. I'm going to save this to disk. File, save as, family, my Revit Families, entourage. Never leave these as just family 1. Cuboid demo. So we'll load this into the project. And put it there on the floor. You know, just like the wall cabinets, we change their dimensions in edit type. And there's height, depth, and width. And I'll make, right here, if I make the depth be 3 feet, and apply, then it becomes 3 feet centered on its middle point. The wall cabinet dimensions are given off the face of the wall, so they come out from the wall instead of going partly back into it. We don't really have a height associated with this. I need to go back and explore that. So let's go back to, edit family, and look at this in a front elevation. And right now we can just drag it like this. Let's create a reference plane across the top that will control its vertical dimension. Create reference plane. In this view, I can't edit the outline of the extrusion, so I'll work with the geometry itself. To make this work, then I drag this down, drag it back up, and then lock it that way. And just to test quickly, dragging the plane now controls the object. And here in the elevation view, I'll add a dimension with a parameter to control the height of the object. Annotate, aligned from my floor level up to there. Pick this, assign the name, height to that. Okay, 2'5". And over here, there's this old one called, I don't know where this came from right here. This is not the one I created. I think I can delete it. Well, ours is the lowercase one anyhow. And if I change the 2'5" to 3, then that goes up to 3 feet. So now when I load this into the project, a couple of questions to ask. It says the previous cuboid demo just had the length and the width. The new one has length and width and a height parameter, and I do want to overwrite the existing version of the geometry plus these new height dimensional parameters. And then we can go to edit type. And let's see what this does. This might be height off the ground. Nope, I don't know what that is, sorry. But we'll change this one to be 12 inches. Oh, that was the width. Sorry, I wanted the height to be 12 inches. The width to be 4 feet. Apply. Okay, so height a foot, depth 2 feet, width 4 feet. So that's the basic procedure for adding control dimensions to objects. And the reason we do it by type, I really shouldn't have made that 4 feet high. Initially, this cabinet was 2'6" high. That's the normal size of things. And if you have 2 of those next to each other, and you want them a different size, the story here is to pick one. Let's say I want these to be 3 feet high instead of 2.5. This is where we go into edit type and duplicate and say 15-inch by, let's say 3 feet high, just to be very explicit about it. That's a different by 36-inch high, we'll say, by 36 inches high. This is a different size and therefore, by definition, a different type than the other. Now I need to change the actual dimensions of it. 3 feet, apply. Okay. So this is a type that's 15 by 36 inches high, and this is the one that's 15 by the standard 2 foot 6 inches high. So if I copied this over here, sorry, control drag. I really should rename this one to be cuboid demo width by depth by height. Let's say duplicate. Width is 48 by depth is 24 by height is 12. Okay. So that's that one. Let's get rid of this actually. And if I copy this over with control drag, I want this one to be 3 feet tall. I go in edit type, duplicate. I'm going to call this 24 by 36 high, just to make clear what's going on there. Make this 36 inches. Apply. Okay. And now these are two separate types of the same family, just the way that these are two separate types of the same geometry. Every instance of a family, regardless of type, can have its own individual offset above its host. I'm going to say offset from host. Let's just make this one 48 inches off the ground. And that's a property of the instance of this one object, not of the type. So that one comes up there at 48, but the big one doesn't. And that's not part of the definition of the size of the object itself, which is what our parameters are concerned with. This is just where it is vertically in space. Let's make a table together. Sound good? Our basic table. So file, new, family. These are standalone files on disk that you can use in subsequent projects and email to people and like that kind of stuff. And this will definitely be furniture. Let's just sketch a little bit to know what we're looking at. We'll make our geometry first and then apply all this stuff to it later. So this is what a bunch of you did, for one of your families. Create extrusion. We'll make this sort of any old size. But what we do want to do right from the outset is to get this centered on the axes so all these equal things work out. So I'll pick it and move from midpoint to there. Move from that midpoint to there. I was pretty close. Let's add the two horizontal planes. Might as well do the verticals as long as we're at it. Here I'll use the CS shortcut for Create Similar to select an existing reference plane and create a new one. And here I'll use the CO shortcut for Copy to copy a reference plane from one point to another. Okay, so there's that. Right now these just sort of coincide in space. So I'll make sure I bring this down, drag it up, and lock it. And you can do this either in the edit extrusion mode or here in the solid mode. Okay, let's put dimensions on here, and then we'll add the parameter names to them. Annotate, aligned, just do that one. And then all the way across. And then once you put the two little ones in, then right now it says these are not required to be equal. It's got the red slash through it, but we want to click that to say, yes, we do want them to be equal. The same thing on the sides. Annotate, aligned. Actually, I realize now that I didn't have to center the geometry on the center reference planes. Setting these smaller dimensions to equal would have done it for me. Okay, let's put some legs in. And the thing with them is if they're quite close together and the tabletop gets big, they're going to be in the middle and the tabletop will rock. So we really need the legs to move with the sides of the table. So I think what I'll do is, can I offset a 4 inches? Well, it seems I can't offset planes, but I can copy them down. I want to put control planes 4 inches in from the top and bottom of each of these. I can just copy this 4 inches. Select it, CO for copy, type 4 inches. Escape. And then I'll move this one in so we'll get an intersection point of these planes for each of the legs. Where these are fairly straightforward. We won't be putting any more planes in this view, but you'll see when you get to some of the window families, they just have all sorts of little tiny dimensions that are variable. Well, some are variable and some are not, but get locked in. And you might have 20 planes in 6 inches or something, and it gets a little crazy. I tend to stay away from them and just accept that somebody's made them correctly and like the manufacturer, and I'm not going to go there. Okay, so we now have these. Let's just say that our legs are always going to be a given dimension in from the corners. I'm just going to dimension from here to here is 4 inches, from here to here is 4 inches, but I won't assign a parameter to that. I just don't want that to be a locked dimension. So, well, let's draw the legs first, actually. Create, extrusion. I'll do round ones. We just have to deal with a center point. And we want to locate that on this intersection so it knows that it's tied to those two reference planes. Got the X there, and I'll just say, I'll say 1 inch radius. We'll start with that and then see where we get. So we got the plan worked out. That's pretty straightforward. So one thing I will do, I'll put on dimensions from here to here, 4 inches, and I want that always to stay at 4 inches. So I'm going to lock that dimension. I'm going to lock. Well, really what's happening, the two center lines are fixed. Everything is dimensioned relative to them. Center planes, I should have said. This outside vertical one is known to be half of whatever our width is. And the one inside it is known to be whatever distance we set in from that one. So if we pick that dimension and then lock it, then it locks that 4 inches apart, even as the plane on the end moves relative to the center plane. And I'll do that for all these guys. And then over here. So the way to see if this is working, before we even go into an elevation view or any of that kind of stuff, will just be to take this one end plane and pull this out. And a couple things should happen. This should pull out, let's say 6 inches. If we pull this one out 6 inches, this one should pull out, to the right 6 inches. And these two interior lines should follow those as they go so that the legs stay the right relationship to the table. So let's just see if that works. I'll just drag that out. Okay, that's just the way it's supposed to work. Always nice in a demonstration. Now let's think about the height. Let's go into an elevation view. Let's just say front elevation. By default, all these things are made a foot high. let's move this up. And let's create a reference plane to define the height of the whole table. Create reference plane. And I'll create one on the bottom as well. Create reference plane. So if we pick this guy, then we can sort of lock it to those two planes. I should have locked it. Click and lock. Drag, click, lock. So as I move the top up, it goes. Okay, that's good. We'll assign dimensions to this. We'll be giving a dimension from the floor up to here, and then from here back down to here. And then the legs need to come up to the same one. I'll pick this leg, drag it up to there, and lock it as well. So putting dimensions on these, annotate aligned. Oh, sorry. Right, then we're going to do from here down to here. And if I pick this, let's say I want to make that 2 inches thick, I'll pick this here, click on the dimension, and make it 2 inches. If I want to make the whole table, let's say 2 feet tall, this horizontal plane controls the top of the object. So if I pick this and say, let's make that 2 feet. Aha, that worked, but I didn't lock this dimension in. I didn't lock the 2 inches. So I'm going to pick that and then lock it to lock in the relationship from the top of the table to the bottom of it. Now I should be able to pick the top reference plane, pick its dimension, type 2 feet, 2 feet, and have the whole thing go down. Okay, that's how that's supposed to work. Sort of figuring out what locks to what and what needs to be left free is part of the challenge and part of the fun. Now I need to put some more legs in there. And if you recall, making 4 separate legs and attaching them all separately is sort of a pain. I'm going to end up making this be, again, we've done it before, one extrusion with 4 separate pieces that will all be the same height. So we can pick the leg, go to edit extrusion, and then I'll just copy it from here. I'll pick the copy command from that intersection to that intersection, to that intersection, and to that intersection. And those are all now parts of one object that will have a single height. And when we go up, we'll be able to see that those all come up to that height. So at this point, in our plan view, we can control this with just by dragging these, but we don't yet have the link over to the parameters. So that's when we pick this dimension, and we're going to call this one width. You know, is this the length of the table, or is this the width of the table, or is this the depth of the table? How about length and width? Length for the one that at least starts out being longer. Length, and this will be by dimensions are almost always by definition by type. So that's a length dimension. And we see length equals, and that's how we know that a parameter has been assigned to it. We could pick this one, assign width to it. Go into our elevation view, pick this one and assign height to it. Let's be able to vary the thickness of the tabletop. So right now it's locked. I want to unlock that. Pick this one and give it a dimension, and we'll call it top thickness. I think that'll work. Let's just see, we can test them out right here in the we don't have to take them back into the model. Over here under family type properties, we get our parameters here, and let's just change the top thickness to 3 inches. Apply. Okay, good. That's as expected. Let's change the height of the whole thing to 30 inches and see if we still get what we hope to get. This kind of testing, called flexing, is an important part of the family design process, so you can be sure the family will behave as expected back in the project. We're at 30 inches for the overall height, 3 inches for the top thickness. Okay, so I think that's ready to go. We might want to come back and round the corners off of the table, something like that, but we can do that later. So let's save this now. File, save as family. I'm going to call it Parametric table, and note that I'm doing this in my own entourage folder. Save. Now I'm going to load it into the project and close it. We've saved it to disk. We don't need to keep it open in this editor environment anymore. The cuboid is still theoretically open, project 1. And this time it did remember to bring this in for us. My 3D view. So here's this. So now we can edit type and make it an even 4 feet long. And 2 feet wide. And so that's fully adjustable. I tell you, while we're at it, let's put a material on that to continue exploring the range of things we can do with families. So I need to go back to edit family, since we'd shut it down. I can't just click to it. And I'm going to assign the top material and leg material parameters to this. So I'm going to pick that, and instead of picking a material, because typically these family templates have relatively few actual materials in here, who knows what all this stuff is for. I really have no idea. But we're going to pick this, and over here, click the little button where we associate a family parameter to this. And we did this last time. We're going to create a material called top material, specific to this family, not to any other families. Okay, and then pick this and leg material, new. And load into project and close. I do want to save the version on disk, which is this RFA, which is the file type for something saved onto disk. It says there's already one there. You want to replace that? Yes. This one has material parameters assigned to it. That's new. And you want to overwrite the existing version and its parameter values. And we have added material parameters, so we do want to update them, so that when we get into a realistic view, all these will be gray default material. But now we can pick this, edit type, and now we have the materials that we want to assign to them as we did in the last class. Polished steel. Okay. Top material. Wood. Okay. Apply. And if we decide we want to have rounded corners, we just go back in here, edit family, get into a plan view, pick this, edit extrusion. I'll pick the fillet arc tool with a radius of, let's say, 4 inches, which will put each leg at the center of each arc. And the reason I'm doing this as a test is to make sure that these long stretches of the sides are still locked to the reference planes, even if I'm sort of messing with their ends by putting the fillets on them. I think we're good. Save it. Yes. Yes. When in doubt, I always just hit this bottom one when I'm messing with the parameters. Okay. So we can go in there and modify the geometry. If I was creating a whole new tabletop, I'd have to reattach it to the reference planes. But since this is the original object, it's still linked into them. I tell you, let's do take a break, and we'll come back and do two that pose different challenges.